Today we're going to be talking about central angles and arcs, and specifically the relationship between the two. So here I've got a circle, and in this circle I'm going to draw a center. All right. From this center, let's go ahead and draw a couple things. So that line right there, that's a radius. I draw another radius to another point of this circle. I'm going to label these with some letters. All right. I'm going to put C for my center of the circle. I'll call this one A and this one B. Okay, so what we've created here is an angle in between. And this is called a central angle because that angle is connected to the center of the circle. And we can label this specifically as angle, and I'm going to start with A, it goes to C, and then out to B. So angle A, C, B is created here. All right, I can draw other angles around this circle. We could have other ones that go off to here and off to here. So let's call that Y and this one Z. So the angle created here, so that's a little sloppy. The angle created here is angle Y, C, Z, or you could also go Z, C, Y. All right, so these are all central angles because they start at the center of the circle. Okay. I'll draw another one over here. I'll call that X. Now, I want to look at this time as an angle from X to C to Z. So go ahead and trace this with me. From X to C to Z. That's this angle here. Okay. You could have also gone the other way. X, C, Z going to the right. But either way, that cuts directly through the middle of the circle. So this time, we can actually put a length on that, or a measurement. Angle XCZ, and I don't know why I'm writing it again, but angles XCZ is equal to 180 degrees, because that's half of the circle. Around the whole circle would be 360, so what cuts it in half would be 180. But nonetheless, all of these are central angles because they go through the center of the circle, or they're connected to the center of the circle. So these are all central angles. All right, we're just describing a couple of them. Now, in relationship to arcs, central angles are equal to the arcs that they create. So central angles are equal to the arcs they create. So I'm going to go ahead and draw ourselves another circle here. All right. And we have the center because that's important to us today. All these central angles have to be put there in the center. All right. So I'll go ahead and draw a couple. Let's say we have something that looks like this. We have N, we have M, we have P. We have a couple more over here. Call that B and call this one A. All right, so it's kind of split up as a pie chart. We can put this with some measurements. So let's say from M to N to P, so this mark right here is 50 degrees. And so let's just look at that pie slice right there. I'm going to trace out the arms of it. So there to there, kind of like a pizza slice. That angle opens up and hits the circle and creates what is called an arc. Consider it like the pizza crust. So that right there, that yellow piece is the arc. So if this is a central angle and the inside is 50 degrees, that means the outside arc is also 50 degrees. So we can label that. That arc is from M to P. So the way we show that is arc MP with that arc symbol above it is 50 degrees. The angle inside is also 50 degrees. Now, if you remember all the way around the circle, all the way around a circle, that's 360 degrees. So eventually everything will add up. We're not going to look at every single piece, but we'll look at a couple. So for example, if I go from A to N to B, that would be this one over here, A to N to B, and we said this was 95 degrees. We look at what it traces open. So pizza slice, and then it opens up and creates this crust over here. So if I know that from angle ANB is 95 degrees, the arc that it opens up and creates from arc AB will also be 95 degrees. So whatever the inside is, that's what the outside is going to be. All right, so nothing too crazy today. The central angle, the inside, is equal to the arc on the outside. So we can use that information to solve for missing pieces. Okay, so let's start with an example here. We'll need another circle. Okay, so we've got J up here, Q in the middle, K, and L. And they're going to say how big, or they're going to ask us how big is the missing angle. And the missing angle they're referring to would be this one right here. Okay, now they do give us some numbers over here. This is 155 degrees, this is 120 degrees, and that's it. Alright, so let's see if we can figure this out. I'm trying to find this piece right here, so I'm going to go ahead and highlight that. I need to find this. That is an angle. And that angle, if we gave it a name, would be from L to Q to K. Or we could start with K, but either way, we're trying to find angle LQK. We don't know that one yet. Alright, but I can trace the arms of it. Alright, so there's the edge of the pizza slice, there's the edge of the pizza slice, and I know that angle inside here should be the same as the arc that is created. And in this case, we do know how big the arc is. And that arc is from L to K. So from L to K is 120 degrees. So what does that mean about the inside one? That should also be 120 degrees because the arc is 120. The angle inside should also be 120 degrees. Whoops. Now in this case, did I even need the 155? No, I didn't. That was just a little extra information. That would tell us how big this one is, but not exactly what we needed it for. So sometimes they're going to give us extra information that we don't really need, but just have to be vigilant of that. Let's try another one. Circle, center, angles. Now remember, a straight line through the center is still a central angle. All right. So we've got F, E, D, C, and B. And they're going to give us 135 degrees and 81 degrees. And now let's take a look at the question or the instructions here. It'll say find CFD arc. So they want us to find out what arc CFD is. So the arc is the outside. If it said angle, that'd be the inside, but we want the outside. We want it from C to F to D. So I'm going to go start at C, go to F, and end at D. All right, so if it's 3 letters, that usually means you're going the long way around the circle. If it just said CD, you would go the short way, like this. But since it's the long way, we're going to go from C to F to D. All right, so I want to start here. I want to end here. Okay. Now, if I take a look at it, I want to go from C to F to D. This whole circle here, if you want to think about it as a pizza, it's made up of 1, 2, 3, 4, 5 slices. From C to F to D is made up of 4 slices. This one, this big one, F to E, and then E to D. So if I knew all of those pizza slices, I could add up all the crust and find out how big it is from C to F to D. All right, so let's look at what we have. We have from F to B is 130 degrees. We have from E to D is 81 degrees. What we don't have are these 2 pieces. But if I did, I could add them all together and find out how much this is worth. All right, so one way to figure this out is kind of just go back and forth between the central angles and the arcs outside. So I know from E to B is 135, so this thing inside is also 135 degrees. That's an 81 out there, so this one's also an 81. Now it doesn't really help us on the outsides, but it helps us see a little bit more on the inside. What we need to find is how big this thing is and how big this thing is. Okay? So let's just go ahead and pick one. I'm going to go ahead and say BC first. I want to find out what this is. All right, I want to find this. Now, once we run out of numbers, you see we've used the 135, it didn't lead us anywhere. We used the 81, didn't lead us anywhere. What we want to do now is look for any other clues that might help us. And in this case, straight lines that go through the middle. So for example, I see that F to C goes straight through the middle. And a straight through the middle is worth 180 degrees. Remember, straight line right through the middle, 180. So I know from F to C is 180 degrees. I already know that this piece here is 135, so there's a way I could find this missing piece here by subtracting. I know from F to C is 180. I know that other chunk is 135, so if I subtract those, I can find this little piece here. So 180 minus 135 gives me a 45 degrees. So that means this piece in here is 45 degrees. And if the inside's 45, the outside also 45. I could do the same thing on the other side, F to E. We could do 180 and subtract 135 again, or what do you notice about these two things right here? They make that X shape, so they're vertical angles, thinking back to our old angle lessons. So if this side's 45, the other side of the X would also be 45, meaning that the outside would be 45. And now, if we check it out again, do I have everything from C to F to D all the way on the outside? I think I do. 4 pizza slices, 1, 2, 3, and 4. So let's go ahead and add them up. Now, just kind of checking ourselves, you see how CFD goes almost all the way around the circle. So it should be a pretty big number. All the way around is 360. So this should be kind of close. So let's add it up. I've got 45, 135, another 45, and an 81. So if we add all that up, it comes out to 306 degrees. That should be pretty close. So what we found here is that arc CFD 306 degrees. So we're doing a lot of puzzle solving today. Sometimes the problems get a little bit tougher, but we have to use our central angles and remember that that flat line through the middle is 180 degrees.